All right, welcome everybody. My name is 𝗦𝗲𝗀𝗀𝗀𝗀, and today we're going to be speaking about, surprisingly, AI, but more specifically, AI infrastructure. I hope you've all been having a great Ignite. Hopefully you all still have some energy for this session. Won't be too long. All right, so like I said, my name is 𝗦𝗲𝗀𝗀𝗀𝗀, and I'm a program manager here at Microsoft on the Azure AI high-performance computing team. Today's session will go over a little bit about AI infrastructure and what exactly that means on Azure and how you can utilize that to run your next AI workload. We're also going to talk a little bit about AI workloads and how to run an AI workload and run it at scale, reliably, and make sure it's performant. Then we're going to talk a little bit about the common challenges that you might face with your AI infrastructure. As models get larger and your solutions get more complex and more user-friendly, the infrastructure layer and what's keeping them all running is usually what takes a hit. And we'll talk a little bit about the Azure product portfolio and the tools that we have here at Microsoft that are actually enabling these workloads. And finally, we're going to discuss a product that was just generally available about a month ago that you all can download from the Azure Marketplace that will help you deploy HPC at scale on Azure. Also, real quick, if you did not get a chance to check out the H200 and AMD GPU SKUs, they're both featured at our Microsoft booth, the infrastructure section. So let's start off by talking a little bit about AI infrastructure. So Microsoft is powered by AI infrastructure. A lot of the common products that you see, like Security Copilot, many of you might be using OpenAI services. All of this runs on a backbone, which is Azure AI. But one level below that is the Azure VM infrastructure. And this VM infrastructure is a vast variety, almost like an alphabet soup of different names and letters, but at the end of the day, it's different types of SKUs and GPUs. We have real-time inference and low-cost compute. These are for your AI workloads. You have distributed training and generative inference type of compute, as well as mid-range training and dense inference type of compute. But it's not just all about compute. There's also other important features like the storage and networking, and all of these pieces come together, and it's what's known as AI infrastructure. But it can be challenging to put all of these pieces together, especially if you're new and you're looking to develop such complex systems. So the team that I'm a part of is the HPC high-performance computing team. Many of you may know about high-performance computing, but this might be a brand new term for you. AI is just another workload for high-performance computing. At the lowest of levels, high-performance computing is using very specialized GPUs, very specialized hardware to run very complex problems in parallel. When I say in parallel, that's where the GPU comes into, that's where the GPU has the advantages. If you're looking for other types of workloads that don't need this HPC, we have CPUs and FPGAs, but all of these different types of hardware come together and really build out, allow you to create solutions. So my team is there in the middle. We're responsible for the operating system, for these VMs, the HPC images, the hypervisor that connects to Azure, the ARM resource manager, as well as workflow orchestration, job scheduling, and as well as the telemetry that you'll get from these machines. So over the last year, we've seen a huge wave of innovation from the industry in AI. And this has led us to develop our own product, which is Azure AI, and then you get to use OpenAI services and build applications on top of it. Maybe you've used Azure Machine Learning. That's another common tool that people have been talking about today, as well as AI Studio. These are all under this umbrella known as Azure AI. One level below that, you have your NVIDIA GPUs, your AMD hardware, as well as our own Microsoft in-house hardware. We're developing the 𝗦𝗲𝗀𝗀𝗀𝗀 chip, which maybe you guys have all heard of, but that is our own chip that's used for these kinds of workloads. On top of that, you see Microsoft Copilot, which is built on top of this, as well as your AI apps that you guys are all supporting. I want to take a step to talk a little bit about the different personas and the different types of users that will be utilizing this kind of hardware, which is most likely the folks that you guys will be interacting with. So at the lowest of levels, we have our AI infrastructure. And the team that you guys will most likely rely on to deploy this AI infrastructure is your cloud ops team. They're directly interacting with Azure. They're deploying landing zones, deploying the networking, deploying the storage. And they really handle the infra layer with Microsoft. One level above that is your system admins. So once your cluster has been brought up, once you have all your infrastructure in place, you have to maintain the system. That's where your system admin comes in. They're responsible for maintenance. They work with the Cloud Ops team and the end researchers, the users of the machines that are submitting the jobs. And they also interact with HPC-specific tools. One level above that is your AI and HPC researchers. These are the folks that are actually using the GPUs, and they're not really too worried about what the SKU is, what kind of networking, what kind of compute is behind all of this. They're more interested in creating solutions, using the machines itself. So they interact with our AI infrastructure by SSHing onto the nodes, submitting jobs, analyzing the results, and eventually coming up with very, very cool solutions. At a very high level, I wanted to just talk a little bit about what is AI training and what is inferencing. These are the types of workloads that most folks are talking about today. And it all starts with gathering up training data. So you load and ingest this data onto your machines. Once you've got those machines, once you got the data onto the machines, you have to actually deploy the infrastructure. Once that infrastructure is loaded, your Cloud Ops team has already done that work. Now you have your researchers that are actually going to be submitting training jobs. These training jobs in the HPC world are most historically Slurm users, Slurm as well as PBS Pro, Altair, LSF. Some of you may know of these third-party job schedulers, but we also have a Microsoft job scheduler that I'll be going into as well. Once you analyze and retrain on the machines, you'll finally have a GPT model. And once you have a GPT model, you can run smaller jobs, and these are inferencing jobs, on that model to generate results. What you most likely have all seen is ChatGPT as a result of this. So the two boxes that just got darker is where I'm going to be talking a little bit about. So deploying the AI infrastructure and submitting your training jobs. This is where a lot of challenges can come up. Actually, in fact, setting up an HPC cluster can take weeks to months, depending on how complex your systems are. So we've developed a tool that is actually going to shrink that time into 15 minutes. An example for running an AI workload at scale versus locally at a smaller scale is running a small GPT-4 model. Anyone can run this pretty simply on their own laptop, but this is just one machine. But how do you run this at scale over hundreds and thousands of nodes? So that's where building out your AI infrastructure comes into play and making sure it is reliable here. So for example, most of the time, the GPU and the hardware is not network topology aware. This is very important as you're working across thousands of nodes that all need to be, you can think about network topology as understanding where the data is traveling, making sure the data is not going over each other, and it's going to the spot that it needs to be. So this is a very complex problem when you have thousands of nodes. The architecture and the setup of this network topology is very important. Next, you have failing hardware. So when you're working with thousands of nodes, most likely you will need all of these nodes to run your workload. But what happens if you're missing just 10? Well, then your job will not actually run. And then you would have wasted some time, you would have wasted some money spinning up those resources, and then you'll have to restart the whole job from the beginning. So this is where the failing hardware comes into play. Next, you've got multi-node workloads running over long periods of time. So all of these nodes are working together, but they're most likely staying online for weeks to months. That's how a large language model is built. It takes a while, or you have smaller jobs that are also running for a while. We have to make sure that the system and the infrastructure has been set properly so that it can stay running, rather than having it come down and then spending time bringing it back up. As AI expands, more data is needed, and that's where storage scalability seems to always there's always an ever-increasing need for more storage. This is to load that data onto your infrastructure. So making sure you've selected the right type of storage that is both performant and is enough for your system is important here. And then it's ever-changing environments. So as we are starting to see in the industry, we're seeing that these inferencing jobs are starting to become more like training jobs. What once was a large training job has now become many smaller jobs that are just inferencing on a larger GPT model. GPT-4, GPT-4.5, but once we've reached a certain GPT model, we need to start using that model instead of making more models. So that's how those small inferencing jobs start to look like training jobs themselves. And then this brings me to the next point, which is actually what is going to be helping us make sure the infrastructure is laid out accordingly. This is a term known as an orchestrator, and then you have a job scheduler. So your orchestrator is responsible for bringing up the infrastructure, making sure you have the right infrastructure for your workload, and then your job scheduler is actually responsible for handling the jobs. As GPU capacity and demand is ever rising, the need for these schedulers are even more important. So what a job scheduler does is an orchestrator handles resource management. The dynamic allocation of resources is very important for these types of workloads. The scalability is also pretty important because say you needed 1,000 nodes, but then after a week you don't need those 1,000 nodes. Rather than your HPC users spending time trying to figure out when to scale down and scale up, we have autoscalers, which is the job of these job schedulers and orchestrators. So they handle the auto scaling, so your builds are also not continuing to run for this. Fault tolerance, so making sure that there are ways to handle failures and ensuring reliability is also important. So we do something called over-provisioning, which means you have a set of backup nodes that are always available in case something does fail. You're able to dynamically access those nodes as well. As well as, automates the complex workflows, which is what I kind of just spoke about with job schedulers, making sure that the tasks and jobs are all sent accordingly, and they run when they're supposed to run. Next, we've got optimized performance, so efficient scheduling and task orchestration for better performance. This is just like the last point a little bit, but mainly to speak about to ensure that the jobs that rely on other jobs are running at the right time. The automation, the efficient scheduling, these are all things that should not be a blocker for developing AI language models or your next HPC workload. And then cost management, which is a little bit into the autoscaler point as well. The resources should not be running while not being used. You want to make sure that you're utilizing your fleet of nodes to the maximum that they should be. You don't want to pay for 1,000 nodes when your job only needed about 700. At the bottom, we can see some of the most common job schedulers. We've got Slurm. For those that are running AKS, we've got Kubernetes and Docker. And then we've also got Azure Batch, which is our cloud custom job scheduler and orchestrator. So Azure does have the complete solution when it comes to running high-performance computing in the cloud. We've got the powerful compute, the virtual machines that are optimized for HPC. We've got high-performance storage for this, so specifically Azure Blob, NetApp files, and managed Lustre, as well as the fast, secure networking. So we've actually got enough InfiniBand in our data centers to wrap around the Earth 5 times. So it's these 3 components, networking, storage, and compute, that kind of enable the AI infrastructure at the lowest of levels. On top of this, we've built workload services. These services help users save time and money to deliver faster results. It's all powered by VM scale sets. So a scale set is just one virtual machine, but it's been multiplied so that you can basically run the same workload, run one VM as if you're running 1,000. The max is roughly, I think, 1,000 right now. Then we've also got Azure Batch, which I just mentioned, and Azure CycleCloud. So those users that are used to using Slurm, PBS Pro, and LSF, with Azure CycleCloud, you're able to actually still use those Slurm schedulers, those Slurm commands that you're used to on premises in the cloud. You would just build out a Slurm cluster using CycleCloud. And then we've also got solutions for those that are running AKS as well, containers. So we've got a lot of different types of AI workloads and customers, especially here at Ignite. I know a lot of you are running different types of workloads, and we've got different solutions for each of you. Those that are looking for a very curated experience can use Azure Machine Learning. This is a portal-like experience where a user gets full end-to-end managed service from end to end. It's a portal where you can select models, you can select infrastructure, and you are mainly letting Azure do most of the job scheduling and the handling of resources and model preparation. Say you want to bring your own application to the cloud. You want to bring your own HPC application to the cloud. This is where Azure Batch can help, where Azure Batch is a cloud-native job scheduler and orchestrator. You're able to connect to other Azure native apps and build on top of them. So these are for those users that are not using Slurm, not using IBM LSF, things of that nature. Yeah, it's an easy way to SaaSify your AI or HPC applications. For those that do want to run Kubernetes at scale, we've got AKS. This is complex container orchestration. So just like running jobs at scale, you need a scheduler for your containers, and that's where AKS comes into play. For those that are used to running Slurm or those third-party job schedulers, that's where you have CycleCloud. And as we move from the left to the right, we're moving more from a managed service to more of a custom development. So with CycleCloud, you have much more closer access to your infrastructure, selecting the type of compute, the GPUs, the compute, the networking, and the storage. So it's topology aware as well, so that's actually very important with the networking. And then for those that are doing IaaS, which is a very custom in-house, almost like an on-premise solution, but you want to run that in the cloud, that's where you have the IaaS customer. So that brings me to the newest product, which is CycleCloud Workspace for Slurm. So what exactly is Workspace for Slurm? So it's a supported solution. It is available in the marketplace. The main goal is to deploy Slurm clusters at scale in Azure. And why did we create this? It was because deploying infrastructure on Azure was taking much too long. Understanding the complexities of Azure does take a while, and for those that are brand new to this, it can be challenging, and almost you might stray away from Azure at that point. So getting ready in minutes and not days. Deploying this infrastructure is now much faster. You're able to get a Slurm cluster up within 15 minutes. And how do you get this? Just from the Azure Marketplace. So I'm going to talk a little bit more about what exactly Workspace for Slurm is, and what is underneath it, and what exactly you'll be deploying. So all those infrastructure topics that we just spoke about, the virtual network, the different storage solutions, the VM, as well as the Slurm cluster, are all going to be deployed after your deployment of Workspace for Slurm. You can access this on the marketplace itself. I do have two demos that I would like to show you guys. It is the deployment of a Slurm workspace, as well as using a very common tool known as Open on Demand, where users in the HPC world are pretty familiar with this, but we'll just take a look at it right away.
Connect to the Azure portal. Create a resource. Search for Slurm in the Azure Marketplace. Select Azure CycleCloud Workspace for Slurm. Hit the Create button. In the Basics tab, enter the subscription and the region in which you want to deploy. Set your logon credentials. Define users' home directories. Create a new or mount an existing one. Add additional file system if needed. Choose between Azure NetApp files or Azure Managed Lustre file system, depending on your storage requirements. Define the networking settings. Use an existing virtual network or create a new one. You can optionally deploy an Azure Bastion or peer to an existing VNet. For the Slurm settings, choose which VM size, OS image and Slurm version to deploy, and if job accounting needs to be enabled. Set how many login nodes should be made available. Configure the HTC, HPC, and GPU partitions. Review and create. Follow the deployment status. Check the resources created. Display the deployment status. When the deployment is ready, use the Bastion to SSH into the CycleCloud virtual machine. Use the key provided during the deployment. Check the log of the installation. Your deployment is now ready to be used. In the Azure portal, retrieve the IP address of the CycleCloud virtual machine. Browse to that address and log in. The Slurm cluster is ready with a scheduler, a login node, and the auto-scaled HTC, HPC, and GPU partitions.
So yeah, just like that, you're able to deploy your HPC environments at scale on Azure. This last image right here is showing the different types of SKUs that we've deployed, the high-performance computing nodes, your HTC nodes, so that's the high throughput side of it, and as well as your GPU nodes. Let's go on to the next demo real quick.
Connect to the Azure portal. Create a resource. Search for Slurm in the Azure Marketplace. Connect to the...
So yeah, this is the UI that you'll see once you've deployed your Slurm workspace for Slurm. This is it's a web portal that shows both the activity on the right side. You can see different notifications. You can see your cluster, your login node, your scheduler node. A user would connect to that login node and then start submitting jobs. And you can create new clusters as well. On the bottom left, you see a plus sign. That's where you would add additional clusters, and then eventually your environment will grow at that point.
Connect to the CycleCloud web interface and add a new cluster using the Open On-Demand application template. Give a name to your cluster. In the required settings, choose a region, a VM type, and an existing subnet to deploy it. In the Advanced Settings tab, specify which authentication method to use between Basic, LDAP, or Intra. Here we will use LDAP to authenticate users in an Active Directory domain. Finally, set the NFS mount options for the user's home directory. Start your cluster. A new virtual machine will be provisioned by CycleCloud, and Open On Demand will be installed and configured. After a few minutes, the Open On Demand machine is ready. We can retrieve its IP address from the property window and browse to that address to log on. Use the HPC admin account and password to authenticate. We are now on the main page of the Open On Demand portal. The next action will be to connect our Slurm cluster deployed with CycleCloud Slurm Workspace. Set the cluster name and the login node to connect to, and hit the Submit button to connect the Slurm cluster. Restart the web server to reconfigure Open On Demand, and voila. You can now use Open On Demand to browse your file, open a remote shell session, list your jobs, or use your preferred integrated applications. Here we will request a new Jupyter Lab session. Use the provided container, set the duration and the partition to run on, and launch your session. If resources are available, the job will immediately start. If not, it will be queued waiting for CycleCloud to provision and configure a virtual machine to run on. When the session is ready, connect to Jupyter. You can now use Jupyter Lab, open and run existing notebooks, or create new ones. When you are done with your session, free up the resources by canceling your job. The virtual machine will be automatically deleted by CycleCloud.
So yeah, that was just one of many demos that we've prepared here for Ignite, and we've got some playbooks online on our website, blog posts as well on how you can run different applications using CycleCloud for Slurm. If you want to try it yourself, you can go to aka.ms, try CCWS for Slurm. I'll be around for questions. Thank you for your time.